everyone, welcome to Math with Miss Kim. In this video, we are going to learn about exponents. As always with these videos, make sure you have something to write on as well as something to write with. Let's begin. This video is broken into 3 parts. This first part, we are going to learn about exponents. What are exponents? So here we have an expression. We have 2 to the n. And you're like, this is really weird. Well, this is an exponent. And an exponent tells us how many factors of the base we should multiply to find the value of the expression. So this number right here, this is our base. And then the variable n at the top right, written kind of tiny, this is our exponent. So exponents are written as a small number to the right and above the base number. Okay, so we have some examples here. We have 2 as our base and then 1 as our exponent. So again, an exponent tells us how many factors of the base we should multiply to find the value of the expression. Well, if the exponent is saying 1 and it tells us that we should multiply to find, it says the factors, tells us how many factors of the base we should multiply to find the value of the expression. That means it's just simply 1 of our bases. Okay? Well, now here we have an exponent larger than 1. So we have 2 as our base and 5 as our exponent. So this exponent is telling us how many factors of the base we need to multiply it. So we have 1, and again, we are multiplying. 2, 3, 4, and 5. And if I were to multiply all of these 2's together, 2 times 2 times 2 times 2 times 2 times 2, I would get, you just break it apart. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 would get us 32. All right, so you might be wondering, well, how do I say exponents? There are 3 ways we can explain this. So again, we have our base of 2 and we have 5 of our exponent. Let's go ahead and label those. So here's our base. Then 5 is my exponent. So 3 ways we can say it. You can describe this as 2 raised to the power of 5. You can also say 2 to the 5th power. And another way you can say this is 2 to the 5th. So here are 3 ways you can describe this base and exponent. So you decide which one works best for you. My personal favorite is the middle one. All right, so that was part 1 of this lesson. Let's go ahead and move on to part 2. In this part, we are going to use meaning of exponents to decide if equations are true. So we're going to be faced with an equation and we have to decide, is this in fact true? Using what we know about exponents. So here we have 2 to the 4th power. Is this actually equal to 2 times 4? And remember, for equations, both expressions need to have the same value. So let's go ahead and solve this out and solve this side to see, are they the same? So we have 2 to the 4th power. And remember, an exponent tells us how many factors of the base we should multiply to find the value of the expression. So with 2 to the 4th power, that's saying I need to multiply the base 2 by itself 4 times. So we have 2 times 2 times 2 times 2. So I just multiplied the base 2 by itself 4 times because that's what the exponent told me to do. And we are trying to see, is this the same as 2 times 4? So 2 times 4 is 8. So we need to see, is this actually 8? Well, 2 times 2, that gets me 4. So I like to just break it apart. 4 times 2 times 2. Is this equal to 8? Let's see. Well, 4 times 2, that's 8. Uh-oh. Then we have 8 times 2. So we see that 2 to the 4th power was actually 16. And 16 is not the same as 8. So we just use the meaning of exponents to decide that this equation is false. Because 2 to the 4th power does not have the same value as 2 times 4. And we just proved it by solving this out. Well, let's look at another example. Okay, here we have 1/5 to the 3rd power. Is this equal to 1 over 125? Well, when working with exponents, the bases do not have to always be whole numbers, as we see here. They can also be fractions, decimals, and variables. So this is our first example of a base that is not a whole number. So here we have a fraction. Well, we know that exponents tell us how many factors of the base we should multiply to find the value of the expression. So our exponent of 3 is telling us that we need to multiply the base of 1/5 by itself 3 times. So let's go ahead and show that. 1/5 times 1/5 times 1/5. And we are trying to see, is this equal to 1 over 125? Well, we just multiply fractions like we know. We multiply the numerators across and the denominators across. So 1 times 1 is 1. 5 times 5, 25. Is this equal to 1 over 125? Let's see. 1 times 1 is 1. $25 times 5 is 125. So we just proved that this expression has the same value as this expression. So 1/5 to the 3rd power is the same as 1 over 125. And again, this was an example of how sometimes you have bases that are not whole numbers. All right. Well, we are now moving on to the last part of the video. In this last part, we are going to evaluate expressions with exponents. So evaluate just means to solve. So we have here 12 times 2 to the second. There's a couple different ways you could solve it, but there's one correct way. So when you have expressions written like this, the key is solve the exponent first. And I'm going to show you why. So let's first solve it the incorrect way. So if you don't solve with the exponent first, you might just multiply the 12 and the 2. So 12 times 2 would get us 24. And then you would raise that to the second power, because people will be like, oh, maybe I'll just tack on the exponent of 2, and that'll give you 24 times 24. And again, this is the incorrect way. Well, let's use this keynote of you need to solve the exponent first. So here, we're looking to see, do we have an exponent? We do, right here. We have the base of 2 raised to the second. And again, the exponent tells us how many factors of the base we should multiply to find the value of the expression. So that's telling me that I need to do 2 times 2. 2 times 2 is 4. So now I do 12 times 4, 48. Which is completely different from this 24 times 24, which was incorrect. So remember, when you are evaluating expressions with exponents, you need to solve the exponent first. You need to solve the exponent first. So this was our correct way. All right, well, let's look at some more examples. Here's another one. 5 to the second power plus 4. And our keynote, solve the exponent first. So I'm looking at my expression, trying to see an exponent. Boop, it's right there. So we have 5 to the second. My exponent rule tells me that the exponent tells us how many factors of the base we should multiply to find the value of the expression. So we have here 5 times 5 plus 4. 5 times 5, 25 plus 4. We get 29. So again, here we solve the exponent first when evaluating this expression. We have one more example. Here we have 1/9 times 1/2 to the third power. And again, we solve our exponent first. And this goes back to this rule of when working with exponents, the bases do not always have to be whole numbers. They can also be fractions, which we have right here. So I need to solve the exponent first. So I'm looking here, I have my base of 1/2. It's raised to the third power. I'm going to solve this first. So 1/2 to the third power is 1/2 times 1/2 times 1/2. 1/2 times 1/2 will get me 1/4. 1/4 times 1/2 gets me 1/8. And again, remember, when you multiply with fractions, you multiply the numerator and then you multiply the denominator. Now we're left with 1/9 times 1 over 8, which is 1 over 72. And that is the answer after we evaluated this expression. So again, in this lesson, we explored exponents. We first talked about, well, what are exponents? We then used the meaning of exponents to decide if equations are true. And last but not least, we evaluated expressions with exponents. And again, exponents tells us how many factors of the base we should multiply to find the value of the expression. Thanks for joining me. See you next time.